Kia ora Year 10. This question is from a practice for the JAF on geometric reasoning, and I'm starting with some of the really tricky questions. This is an extended abstract question where you have to prove something. And in this question, what we've got to do is to prove that two angles are equal. Now, when you first start doing proof questions, which is what we're just about to start on, they seem really weird. There are no numbers, and we just have to work very logically to show that something must always be true. So in here, we've got to find out first what we're trying to do. Well, we're trying to show that the marked angle EBA, so here's E, B and A, so we're trying to show that this angle here must be the same as angle BDA over here. One of the things that's going to help us is to be really clear with our labelling, and we're probably going to want to write in some other angles, and we might want to draw in some extra lines. So let's think about where we might start with this and what's interesting about the diagram we've got. Well, we've got this line here, CBE, and this is a tangent to the circle. So if you think about your tangent and circle rules, the main one that we've looked at in Year 10 is the rule that the tangent must be perpendicular to the radius. So let's see if we can somehow use that. Well, we haven't got a radius drawn on here, but we can draw one in. One thing that I think is important to check is whether there are any parallel lines in here. Sometimes the way the diagram is drawn can make it look like there are parallel lines, but in this one there aren't. Okay, so you've got this line here, AD, and it looks kind of parallel to this. It's not, right? We can't make that assumption unless we've given parallel line markings. So we're not going to be using our parallel line rules. Well, at least it doesn't look like it. But we could put on our radius. So let's go to that point that we've got marked in the centre and draw in the radius. And when we've got a line segment, we also want to label that point. I'm going to call that point O. Now what that did is it let me suddenly have some extra angles to work with. What do I have to show? Well, I have to show that this one here, which I'm going to call X, is the same as this one here. So we'll start by saying let angle ABE equal X. And OB is a radius. So that means that if I look at all of this, it has to be equal to 90 degrees. So let's call this little bit that we don't know Y. So X plus Y equals 90 degrees, and the reason for that is that the tangent is perpendicular to the radius. So every time we write a statement when we do a proof, we give the reason. Okay, so that tells me that, it doesn't tell me that much yet, but we're going to be able to use this. So have a look now at that diagram and see if there's another line we could draw in that would let me use another piece of circle geometry reasoning. Okay, well hopefully you saw that we can draw in an isosceles triangle. So look at that. Now we've got a little triangle and a big triangle. So we know that this angle here must equal this angle here. We know that X and Y are linked because they have to add up to be 90 degrees. So I'm going to proceed as follows. I'm going to say that Y is equal to 90 degrees minus X. I haven't used a new reason for that. Okay, that's still just coming from this idea here. But the new thing that I can say is that angle OAB is also equal to 90 degrees minus X. Okay, so that's this one here, right? We know that this angle here is 90 degrees take away X. This must be the same. And the reason for that is that we've got the base angles in an isosceles triangle are equal. So you'll see that what I'm doing is I'm not really worrying about this thing over here yet. I'm just logically going through step by step to see how far I can get. So this all came out of the first idea, which was that the tangent was perpendicular to the radius. And that let me draw in this angle here, Y, and now this one over here. Right? So let's take some of this off. So we've found this angle, and we've found this angle. Now you might be able to start to see where we're going now. We're trying to show something about this angle, but this is the center point. So we're going to be able to use my angle at the center reasoning. To do that, I know the value of this angle, and I know the value of this angle. Those two, and this one here, have got to add up to 180. So that's the next thing I'm going to say. Let's look at our label here. So this angle is BOA. Angle BOA is going to equal 180 degrees, take away 2 times the base angles. Now, I don't need that times sign. Right? All I have to do now is to expand out my brackets, and I get 180 degrees, take away 180 degrees, plus 2x. So that equals 2x. So we're just about done. What we've shown, I'll just clean up some of this a little bit. What we've shown now is that this angle is x, this angle has got to be 2x. But if this angle is 2x, then the one we're interested in must be half of that because of the angle at the center. So angle, what am I going to say now? Angle BDA is equal to half of 2x, and that's because the angle at the center is twice the angle at the circumference. So that equals x, and x was what we started out with, which was angle. Okay, so let's just see what we've done. Well, we started off with this angle here, and now through a series of logical steps, we've shown that it must equal this one here. So we've finished our proof. So we write down as required. So this, for some of you this might feel really easy, but for lots of you it probably just feels a bit strange, right? What we're trying to do is to go one little baby step at a time, and then we write down the reason. So a good proof should have, it's fine to have diagrams like that, although we don't really want to have that much muck on them. So let's take off some of that. What we need to have in a proof is we need to have clear reasoning. Okay? And often when you've done a proof once, it's a really good idea to do it again. So that's what I'm going to do now, with a little bit less explaining. Okay, so let's go all the way back to the start, and I'll do it a second time. And I'm sure there's probably no one still watching, but maybe one of you is watching. Okay, so proofs get much easier the more we practice them. So let's just now do it knowing where we're going with it, and knowing that this reasoning is going to help us with other tricky problems. Okay, so all the way back to the start, how do we do it? Well, we start by saying we're going to use the tangent as perpendicular to the radius. So we draw my radius in, draw it in here, put in point O. Label this as x, so we're going to write that angle OBA plus x is equal to 90 degrees. And the reason for that is that the tangent is perpendicular to the radius. So angle OBA is equal to 90 degrees minus x. That's there's no reason for that one. The next thing we're going to do is to draw in this one. So angle BAO is also equal to 90 degrees minus x, because the base angles in an isosceles triangle are equal, and we've got an isosceles triangle because we have equal radii. Let's make that a bit nicer. Here we are. Always better if you can rule up your lines nicely. Okay, so there's that, and now we can say angle BOA is equal to 180, minus 2 times 90 minus x. I actually forgot my reason for this before. It's angles in triangle equal 180. So that gives me 180 minus 180 plus 2x, which equals 2x. Finally, angle BDA is equal to half of that, and that's because the angle at the centre, not angles at the centre, the angle at the centre is equal to twice the angle at the circumference. And that angle x is the angle we were asked about, which was angle BDA. So we're finished, so we just write, we've done it. In a maths language, we write that as required, but if you're me, you put a big smiley face, because it's quite satisfying to have shown something with no numbers in it that must stand up just by a series of logical steps. So there you go, a very long video where I did it twice. I hope that made sense. Leave me any questions or comments, and I'll do some more of the JAF practice later on today.